Hello everyone. In this video, we'll talk about fitting of a probability distribution. To be very specific, fitting of a binomial distribution. What do we mean by fitting of a binomial distribution? So here we are talking about fitted or fitting, right? It means that to find out the expected frequencies of that particular data. So to find expected frequencies, also called as fitting of a probability distribution. Here they are talking about 8 coins are tossed at a time 256 times. That means here they are talking about 8 coins. So small n is 8. And the total frequency, what they are doing is experiment is 256 times. That means capital N is 256. Since it is a coin tossing experiment, of course, it follows a binomial distribution. So the probability mass function of a binomial distribution will be NCX, P to the power of X, Q to the power of N minus X. Right. So I can rewrite this as 8CX. P will be for a tossing of coin. P also, probability of success also will be half. Failure also will be half only. So I can write this as 8 minus X. And since both are having the same base, I can add the indices. So it will become now 8CX into half to the power of 8. So, or I can say divided by 2 power 8. So ultimately the probability mass function becomes 8CX by 2 power 8. Okay. Now what do we mean by expected frequency? If I say expected frequency, I will write it as EF. EF for a particular value X is calculated as the total frequency, which is your capital N, multiplied by its corresponding probability, multiplied by this. So what is total frequency? It is 256. And the probability already we calculated, it is 8CX divided by 2 to the power of 8. What will be 2 to the power of 8? Just a minute. So 2 power 4 is 16. So it is 16 into 16. So it becomes 256. So this 2 power 8 is also 256. That means this and this will get cancelled. So ultimately we have the expected frequency as 8CX, right? So now when a coin is 8 coins are tossed at a time, what are the possible values of this random variable? Means our X can take values. X can take values means in each trial you need not have any head at all, because that is they are talking about success as getting a head. Means all the 8 coins can give me a tail. That means there are 0 heads possible. One is 0. Another one is 1 head can be possible. Then 2 heads possible. 3 are possible. Like that, all the coins can also give me heads also. So 0 to 8 are the values what X can take. Now, for each of these X values, we need to find what will be the expected frequency. Let us go to the next slide. Number of heads, as I told you, it can be 0, it can be 1, 2, 3, 4, 5, 6, 7, and 8. Then expected frequency, already we know it is 8CX in the previous slide. We already calculated 8CX, that means it is 8C0. In this case, it will become 1, okay. Then 8C1, it will become 8. 8C2, it becomes 8 into 7 by 2. So 56 by 2, which becomes 28. Then 8C3, it becomes 8 into 7 into 6 divided by 3 factorial, 3 into 2 into 1. This I can cancel with this. So I will get 56. Then 8C4, that becomes, I have to expand it for 4 numbers, means 8 into 7 into 6 into 5. Then the denominator I can write it as 4 factorial, 4 into 3 into 2 into 1. So now this 4 and 2, I can cancel with this 8, and then this 3, I can cancel with this. So this becomes 70. 5 into 2, 10, 10 into 7, 70. Then 8C5. NCR is NCN minus R, so I can write it as 8C3 also. 8C3 already we calculated, it is 56. 8C6, it is NCR is again NCN minus R, so I can write this as 8C2. 8C2 we already calculated it as 28. Then 8C7 can be written as 8C1 using the same logic, NCR equal to NCN minus R. That works out to 8. Then 8C8 is nothing but 8C0, and which is 1. So we got all the expected frequencies. The question talks about find the expected frequencies, that we did, right? And tabulate the results. So only these two columns gives us the answer for the first question. First question is our question A, means these two portion talks about our question A. Okay, what is question B? Also obtain the values of the mean and standard deviation of the theoretically fitted data. So whatever we did, that is the theoretical values. Now we need to find out the mean and standard deviation. For finding mean, we need to have the formula f into x summation divided by capital N. So let me write that formula here somewhere. Mean is nothing but summation of fx divided by capital N. That we will have to find it. Then standard deviation, the formula is square root of sigma f into x square divided by capital N. This is nothing but x bar, right? So minus x bar the square. That means we need to find out what is summation of fx. We need to find out what is summation of fx square. That is what the table is created accordingly in the previous slide. Here it is. So f into x, that means this f into this x. 1 into 0, it becomes 0. 8 into 1, it is 8. 8 into 2, it is 16. 56 into 3, that works out to 56 into 3. It is 168. Then 70 into 4, it is 280. 7 fours are 28, okay. 56 into 5, that is working out to 280 again. 56 into 5. Yes, 280. Then 28 into 6. That is working out to 168. 8 into 7, it is 56. And then 8 into 1, it is 8. Now let us add and see what is the total. So 8 plus 56 plus 168 plus 280 plus 168 plus 16 plus 8. That is working out to 704. Now, 704 divided by the total frequency. What is the total frequency? Add some of these things. It should work out to 256. Let us check. 1 plus 8 plus 28 plus 56 plus 70 plus 56 plus 28 plus 9. So yes, it is 206. So total of this frequency is 256. Total of fx is 704. So 704 divided by 256. That is something wrong. 0, yes, 8. This is, here I made a mistake. I'm sorry. This is not 16, it is 56. 28 into 28 into 2, it should work out to 56. So earlier I wrote 16. So 704, I will subtract 15, add 56. So 744. This is 744, not 704. Yeah. 744. So 744 divided by 256. This is, let me redo it. I'm sorry. 8 plus 56 plus 168 plus 560 plus 168 plus 56 plus 8. Yeah, I think I made a mistake while calculation. The total, this is working out to 1024. 0. Yeah, so that means, let me do it here. This will be 1024 divided by 256. That is how much? It is 4. That is, using this data, we arrived at the mean of 4. Okay. Now let us go back. Do this f into x, f into x square. That means fx into x. 0 into 0, it works out to 0. Right. Then 8 into this 1, so that is 8. 56 into 2, it was 112. 56 into 2, yes, 112. 168 into 3, it is 504. 280 into 4, it is 1120. 280 into 5, it is 1400. 168 into 6, it is 1008. 56 into 7, it is 392. 8 into 8, it is 64. Now let us add this 64 plus 392 plus 1008 plus 1400 plus 1120 plus 504 plus 112 plus 8. So that is working out to 4608. Let us try that here. 4608 divided by 256 minus 4 square, and then taking a square root, divided by 256. That is working out 18 minus 16, so it is root of 2. You may wonder, how did I get a doubt about this calculation of earlier I wrote something like 700 or something I wrote, then I said something wrong. How I know that? Because mean of a binomial distribution is n into p. Here we know n is 8 coins, and the probability of success, it is, what was that? Is half, right? Probability of success was half. So if I multiply, I should get the mean as 4. And this, the calculated value of mean and this value should match, 4 and 4. Since it was not matching, I had a doubt that I would have made some mistakes, right? Same way, standard deviation of a binomial distribution is, we know, square root of n into p into q. This is what, this we can use it as a check. It is square root of n, that is 8. Then p, it is half. Q, that is also half. So it is actually 8 by 4, it is 2 or root 2. That also should match, right? That is why I had a doubt that time. And then in this particular question, you are supposed to do all this, I mean, this calculations. You can't do directly mean of a binomial distribution, because here you are using this expected frequencies to find out the mean and the standard deviation. That is the question. Also obtain the values of the mean and SD of the theoretical data. So these are all theoretical data. Using that only you have to find out. But very well, you can use this particular thing for your checking purpose, right? So this was asked in one of the MBA exams of Mysore University, in their question papers, for the semester question papers. This question was asked. Right. Now let us move on to the next question. In a binomial distribution, if mean is k times the variance, mean is k times the variance. This is in binomial distribution. That means we know mean of a binomial distribution is n into p. Variance, we know it is n into p into q. So I can both sides divide it by n into p. So to get 1 equal to k times q, which means our q will be 1 by k. Now, what is the question? Question is to find the value of k. That means k is 1 by q. Suppose if the answer has to be expressed in terms of p, then I can very well write 1 by 1 minus p, because q is nothing but 1 by, sorry, q is nothing but 1 minus p. So I can write that way also, right? So this is a simpler one. Based on the question, you just simply wrote the formula for mean and variance of a binomial distribution and then evaluated the value of k. That is what the question is. Right? So here itself, I could have jumped from here itself. I could have jumped to this particular step. Need not have this q or something like that. I could have jumped there and then replaced the q with 1 minus p. Right? If you feel that the contents of this video to be good enough, I request you to please like, share, and subscribe to my channel. Thank you. Take care.